we'll talk about a data structure called as queue. So queue data structure works on a principle of first in, first out. That is, the element which is inserted first into the queue is the element which is deleted first or removed first. Let's see what is the working principle behind it. We have a separate video in which we talk about motivation for shredding queues and stack, and I suggest you go through that video before getting into the logic behind implementing queue, so that clarifies you why do we use queue and why we design it in such a way. So for this we'll be using, to explain the working principle of a queue, we'll be using an array, and if it is an array, the index starts from 0. The size is 6. Let us assume the name of the array itself is queue. I'll be taking two variables, front and rear. Both of them are initialized to -1 initially. Let us look at first insert function. So first, how do we insert a value into a queue? So what is the logic which we follow? So this is a array. Obviously you are using the base data structure or base data structure for storing the element is an array for you, and array indexes can be accessed using the name of the array and the index value. But we'll try to access and we'll try to restrict some part of insertion deletion such that it as per our requirement. Okay, so the insertion happens in this way in a queue. Okay. So suppose for example, if I want to insert an element called as 9, first I have to check whether queue is empty or not, because if I want to insert an element, there must be some memory locations available to me in an array. If there is no memory location, free memory location, I cannot insert the element. So for now, let us assume that, or first I will look into, once we come to the end of this function, how do we insert, I will also come across what is the condition. For now, just let us write like check if queue is full. If queue is full, if this condition satisfies, then you stop. That is, you cannot insert into a full queue. That is, if all the memory locations are filled, there are no free memory locations to you, you cannot insert it. Else, what do we do is, else if you are at this part, it implies that there are some free memory locations. There is one condition which you have to check, that is, if this is the first element which you are inserting, if this is the first element you are inserting, then for now increment front value. You will come to know about what is the significance of incrementing if inserting a first element once we come to the concept of deletion. Okay, but for now remember, if you are inserting a first value, okay, then you increment front by 1. So how do we check whether I am inserting the first value or not? If there are no elements, in a queue, okay, that implies that front value is -1 and also rear value is -1 for us. Okay, so using this condition, that is, I'll be writing else if front is equal to -1 and rear equal to -1, I simply say front equal to 0. Front gets incremented, that is, I initialize front to 0. Just for now, remember, you have to do this. You will understand its significance once we talk about deletion. And after doing this, then you increment the rear value. So this is one block of code for you. So this is one block of code inside the loop. Then after doing this, you say that rear equal to rear plus 1. You increment the rear value, and then in the incremented value, wherever you are incremented, you insert the element. So this is your algorithm for inserting an element into a queue. That is, you check if queue is full. If queue is full, you stop, you don't proceed any further, and we'll write this condition in a while. Else what you do is you check whether you are inserting a first element or not. Okay, the significance of this condition will also be explained to you by the end of this video. So if how do you check whether you are inserting a first element or not? When inserting a first element, or if there are no elements at all in a queue, then front and rear are initialized to -1. This is our initial condition. When front and rear are -1, then obviously you are trying to insert a new value. Okay, when you are inserting element 9, that if this is a first element, front and rear value will be -1 for you. Then when this happens, you just increment front, that is initialize front to 0. Then after this you increment rear value, and at the incremented value index you insert the element. Let us see how this happens. So let us insert the element. So the element which you want to insert is 9. We have to check if queue is full. So usually for now you look at this queue and you assume that the queue is not full because there are no elements. Usually once you see this, you can go through it. We'll come to this condition, we'll see what should be this condition. First condition fails, that is there is some free memory locations for you. You come to the else part. In your else part, what you do is you check whether you are inserting a new element or not, first element or not. So what is front and rear values for us? -1. This condition satisfies, so front is initialized to 0. Then after that what do? You increment rear value. Rear is equal to, rear value is -1, rear value is equal to -1 plus 1, which is 0 for us. Then I say q of rear, which is 0, is equal to 9. So 9 gets inserted here. So this is our first insertion condition. At this point front is pointing here and also rear is pointing here, the same index. Okay, now I want to insert an element 10. Same conditions, that is check whether queue is empty, condition queue is full, condition fails, that is there are some empty locations for me. You come to the else part. In your else part you check whether you are inserting the first element or not. So what are front and rear values for us? Front value is 0 and also rear value is 0. So this condition fails for me. That is I am not inserting the first element, there is already an element inserted. You come to the next part. Now what you do is you increment rear. Rear gets incremented by 1. Previous value of rear was 0. So 0 plus 1 is 1. Then you say that q of rear, that is q of 1, is equal to element 10. So element 10 is inserted here and rear is pointing towards index 1. So by this, if you look at the generalized form of it, if you want to insert an element and if there are free memory locations, you increment rear and you insert at that incremented index. That is the simplest form of explaining it. That is, if queue is not full, you increment the rear value and you insert at that incremented value. Okay, so let us continue. Let us try to insert all the elements. Suppose if I want to insert element 11, the same process. But first condition fails, queue is empty because I can see some free memory locations here. Come to the second part, I am not inserting the first element because front value is for me 0 and rear value is 1. So obviously this condition fails. I come to the next instruction, that is rear gets incremented by 1. 1 plus 1, which is 2. Then I say that q of 2 is equal to 11. Okay, so 11 gets incremented here and rear is here. Okay, now if I want to insert element 12, the same process. First conditions fail because I have some free memory locations. Second condition, I'll be checking whether I'm inserting first element. This is not a first element to be inserted because front value is 0 and rear value is 2 for you. Front value is 0 and rear value is 2 for you. Here itself we can check rear value is 2 and front value is 0. Then you say that rear is equal to rear plus 1, that is 1 plus 1, sorry 2 plus 1, which is 3. Then you say that q of 3 is equal to 12. So rear gets incremented and value 12 is inserted. Similarly, if you want to insert an element 13, then first condition fails because I have some empty locations here. In your second condition, I check whether I am inserting the first element or not. No, the front value is 0 and rear value is 3 for me, so this is not a first element. So immediately what do I say? R is equal to 3 plus 1, rear is equal to rear plus 1, which is 4. Q of 4 is equal to 13. So Q rear gets incremented and I have the value 13. Next, if I want to insert an element 14, then first condition fails because I have one memory location available here. And next, what is your second condition? I have to check whether I am inserting the first element or not. No, this is not the first element because rear value is 4 and front value is 0. This condition fails. Then immediately what do I do is R is equal to R plus 1. Then you have 5. Then you say Q of rear, that is Q of 5 is equal to 14. So you increment rear and insert the value 14. Now if I want to insert an element called as 15, then I check first condition, that is if Q is full or not. Yes, Q is full. There are 2 free memory locations. At this point, what is your rear value? At this point, what is your rear value? Rear value is 5. So when rear value is 5, your Q is full. And what is your n value? N value is 6. What is n minus 1 for you? 5. So when rear value is equal to 5 and n minus 1 is equal to 5, then Q is full. So when rear is equal to n minus 1, that implies that Q is full for you. So this condition can be written as if rear is equal to n minus 1, that implies that you have to stop. There are no more elements. You cannot insert any more element into that list. Okay, so this is how your insertion algorithm works for queues. Okay, so let us talk about deletion. So the same, let us take the same array. So rear is pointing here and Q is front is pointing here, and name of the array is Q. Okay, now we'll talk about deletion. How do you delete an element? Okay, so first and foremost thing is if you want to delete an element, you just increment front value. That is how you delete it, similar to your stack, where if you want to delete an element, you decrement the top variable. Okay, so let us write a function called delete. Delete function deletes the element to which the front is pointing to. So deletes or returns the element to which front is pointing to. Okay, and as we are talking about integers, the return type of this function will be int for us. So how does this function proceed? There will be a lot of modifications which I will be doing once we try to solve the examples. So what does this function does is, so first and foremost thing is I have to check whether Q is empty, because from an empty Q you cannot delete an element. So when do you how do you know that the Q is empty? If front is equal to minus 1 and rear is equal to minus 1, this implies that Q is empty, because initial conditions were front. These were the initial conditions for you. When these were the initial conditions, there were no element in the list. Okay, then you inserted the elements. Then if it was a first element, front got incremented to 0, and the subsequent elements you incremented the front value there. Okay, so if front is equal to minus 1 and rear equal to minus 1, that were the initial conditions, and there also Q is empty. So you cannot delete from an empty list. So first and foremost thing is you have to check whether Q is empty. If front is equal to minus 1 and rear is equal to minus 1, you say stop. That is, you cannot delete from an empty Q. Then you come to the else part. In your else part, what you do is you have to just, let us assume that you take a variable called x. Okay, x is equal to q of front, that is you store that value in a variable called x, then you say that front is equal to front plus 1, and then you say return x, that is the element which you have deleted. There will be few more additions, few more conditions added here. By the end of the example you will understand what are those conditions. Okay, so for insertion what you do is you increment rear and you insert the element. So for deletion what you do is you just increment the front value. Okay, so before incrementing the front value you just store that value into a variable called x, and then you increment front. Okay, and then you return that value x. So for that main function you return the value x which has to be deleted. So as you can see, 9 was the element which was inserted first, and it is the element which will be deleted first, and obviously 14 was the element which was inserted last, and it will be the function, it will be the value which will be deleted last. So first in, first out. So element inserted first will be the element to be deleted first. Let us look at the examples. You will understand them once we take a few examples here. So if I call the delete function, okay, so what happens is, first and foremost thing is I check whether if front is equal to minus 1, or so what are the first condition, I check whether front equal to minus 1 or a is equal to minus 1. What is front value for me? Front is 0 and r is 5 for me, so condition fails. I come to the else part. In else part I say that x is equal to q of front, that is q of 0, x is equal to 9. Then front gets incremented to plus 1, that is 0 plus 1, which is 1 for me. So front gets incremented to 1 and I return the value of 9. First delete. Okay, next again I call the delete function. Then again I will be checking whether q is empty or not. No, q is not empty. I come to the else part. I say that x is equal to q of, what is front value for us? 1. So q of 1, which is 10. Then I say that front is equal to front plus 1, so that is 1 plus 1, which is 2. Then I say return of 10. So front value gets incremented and 10 is returned to the calling function. Similarly, if I call delete function, what happens is again I check q is not empty for me. Now if q is not empty, then I simply say x is equal to then I say x is equal to q of front. What is front value for me? 2, which is 11. Then I say that front is equal to front plus 1 and return 11. So front value gets incremented and you return the value of 11. Again you call delete function, the same thing, q is not empty. You say that x is equal to q of front, which is nothing but 3 for you. Okay, so and 3 value is 12, and then you say that front is equal to front plus 1, that is 3 plus 1, which is 4, and you say return of 12. So front gets incremented and you return the value 12. Again you call the delete function, same thing. So remember, all these elements are deleted for us and we don't have the concept of deletion. We are just forgotten that they are not available. And next is we have a concept called as circular queues. In circular queues we'll look at how do we utilize these deleted positions also. Okay, how do we utilize these deleted positions also, we'll look at it. Okay, for now, once they have deleted, you cannot go back and you cannot reuse the empty locations here, you cannot override them, that is you are just forgotten them. Okay, then you talk about deletion. Your deletion, again you call the function called delete. The same thing, q is not empty, there are some more elements, that is f is not equal to minus 1 and a is also not equal to minus 1. Then I say that x is equal to q of 4, which is 13. Then I say that front is equal to front plus 1, 4 plus 1, which is 5. Then I say return of 13. So front gets incremented and 13 will be returned for me. Again I call the function called as delete. Now here, after deleting 14, there will be no elements in the array. To symbolize that there are no elements in this array, to symbolize it, what I have to do is, once the last element in the queue is also deleted, I'll be again reinitializing front and rear to minus 1 to say that all the elements in the list have been deleted. Okay, so how do I know that whether I'm deleting the last element or not? If front is equal to rear, that is if front and rear are pointing towards the same index, that implies that I have come to the end of a queue and this is the last element, and then after deletion of last element, again friend and rear should be initialized to -1. So for that I'll be adding a condition here. So I'll be checking if friend is equal to rear, then I say that friend equal to -1 and rear is equal to -1. That is the condition which I have to add there inside the else part. So now front and rear are pointing towards the same index. So what do I do is first I make friend, yeah, because so sorry for the inconvenience here. What you have to do is this condition, instead of having it here, you just first remember the x value. First you remember the value which you want to store, that is, otherwise if you initialize f2 -1, this condition will be nullified, that is q of front means q of -1 will be happening. So what you do is when this happens, what you do is you just, if this happens, that is if front and rear are front is equal to rear, what you do is simply before reinitializing it, you say that x is equal to q of front. You just add one statement inside the statement itself. Okay, so if you want to look at the else condition here, so let me write down the else part clearly in the next slide. That is else if front is equal to rear, then what you do is before reinitializing them to -1, you say that x is equal to q of front, and then you say that f is equal to -1 and rear is equal to -1. Okay, then the other thing continues. Then you have, what you have is, then you say that then when this and inside this itself you can say return. Okay, after reinitializing them to -1, you just say return, and rest of the things will be same for you. That is x is equal to q of front is equal to front plus 1, return x. Okay, so here also you have return x. So this condition is for deleting last element, and this condition and this part of the instructions is for deleting rest of the elements. Okay, so last element is a special case for us. When after deleting the last element, the q has to be reinitialized to -1. That is why what do we do is with the same process will be followed here. That is, I remember the x value, then I make front and rear as -1 to symbolize that all the elements have been deleted, and I return the deleted elements. That is what we have done. So here in the else part, here whatever the circle which I have drawn, in here you have to include this else part. So this is about deleting an element from a queue. Okay, so what are the conditions which you have to remember? First and foremost thing is, for deleting an element from a queue, you have to check whether queue is empty. You cannot delete from an empty queue. For that you have this condition. If front and rear -1, that implies that queue is empty. You stop. You cannot delete from an empty queue. Then what you do is, if this condition does not satisfy, that means there are some elements that can be deleted. Then you check whether you're deleting the last element or not. If you're deleting the last element, you remember that element and you reinitialize your front and rear to -1, and you return the element and you stop the program. Else, if you're deleting any other element apart from the last element, what you do is you just remember the element which you are going to delete. X is equal to q of front. You increment the front value and you return the deleted element. Okay, so this is about queue insertion and deletion. In next video we'll talk about circular queues, which are a special case of queues where we'll be utilizing the empty locations which gets deleted here. Whatever the values which are deleted here, we'll utilize them. Okay, thank you.